So if I have more than one variable, right, the letters, what we're going to do is solve for one of the letters. This tends to be the area that messes most people up. They get really confused when I add more than one letter to an equation. But the premise is still the same. We're still talking about isolating a variable, getting something equals. So if I say to solve for x on this equation, 2x minus 5 equals 13, we're still going to be using opposite operations to isolate the variable, right? The whole idea is to get x all by itself. And so we're going to look at this and we're going to go, okay, well, I'm going to add 5 to both sides. And I'm going to get 2x equals 18. And then I've still got this 2 multiplied times x. So I'm going to do the opposite of multiply, which is divide by 2. And I'm going to get x equals 9. Right? And that's the kind of stuff we've been working on. But what if I asked you to solve ax minus b equals c for x, right? We still want to solve for x, which means I want that x to be all by itself. And what we're doing here is essentially the same problem, right? I have minus b here, so I'm going to add b to both sides. And I wind up with ax equals c plus b. And now if I look at this, the only thing I have on that x is the a that's being multiplied to it. So I'm going to divide both sides by a, and I wind up with x equals c plus b over a. So if you notice, they use the same exact operations to isolate, right? They're very similar in how we solved them. But if you notice the literal equation right here, it doesn't simplify nicely. And it's because we have those multiple variables that we can't combine together on the other side. I can't get a pretty answer with c plus b divided by a like I can with 13 plus 5 divided by 2. It's going to be a little bit different, right? But the whole idea is to figure out what variable you're being asked to solve for and get that by itself on one side of the equal sign. And so that's pretty much the lesson. Everything else is just examples so that you can see how they work, right? So if I have, for my first example, A equals L times W, right? That's the area of a rectangle, really. It's a formula for the area of a rectangle. And I ask you to solve for W. That means we want something that says W equals, right? We want to get W all by itself. So if we look at our equation, A equals LW, right? That's saying L times W. So if I want to get this W by itself, I could just divide by L. But I also have to divide this side by L, right? And if I look at that, these L's will cancel each other out, and I will be left with A over L equals W, right? If you notice this, if you pay attention to this equal sign can work either way, right? I could write this as A over L equals W, or I could write it as W equals A over L. It's an equal sign. We can interchange them, right? Either form is a correct solution. But the idea is you want W, whatever it is you're solving for, and in this case, that's W, to be the only thing left on that side of the equal sign. So if I have, say, the distance formula, right? Which would be d, which is distance, equals rate times time. So I have d equals rt, and I want to solve it for t. That means that is the letter that I want to get all by itself. So again, I have this r times t, so I'm going to divide both sides by r, right? These r's are going to cancel, and I'm going to be left with t equals d over r, right? And it's really good to know how to do this, because if you're ever solving formulas and you're trying to figure out what one piece is, what do they want to know? Do they want to know the time? Do they want to know the rate? Or do they want to know the distance? Whichever one of those things they want to know is the thing that you're going to want to isolate, and then just plug in numbers for the rest. What if I have something like m equals c minus s, and we want to solve that for c? That means we are going to want to undo everything that's being done to c. So the only thing that's being done to this c, the only thing that's attached to it, is that we're subtracting s from it. So I'm going to go ahead and add s to both sides, and I get m plus s equals c. That is our final answer, right? We have that solved for c. C is the only thing left on that side of the equal sign. Let's look at another one. Let's go with how about, I don't even know what this formula is, 'cause it's a capital D, so it's not distance. Oh, you know what it is? It's density equals mass over volume. We've got D equals M over V, and we want to solve it for M. We want M to be the only thing on this side of the equal sign. When I look at this, if you notice, we are dividing by V. The only thing that's being done to this M is we are dividing V out of it. So I'm going to do the opposite of division, and I'm going to multiply this side by V and this side by V. And I get dV equals M, because those will cancel. And so we are now solved for M. We would know what the mass was. Sometimes they'll get a little bit more complex. They'll look simple, and then they'll be a little bit more complex. So if I have a problem that looks like A equals pi r squared, and I want to solve it for r, we can get that r squared by itself, but then we're going to have to take the square root of everything, right? But we're going to start with what's being multiplied to it. So here I've got pi times that r, so we're going to start by dividing out the pi, right? And I get r squared equals a over pi. Now, that would be well and good. We've got that r all by itself, but it is squared, and we don't care what r times r equals. We want to know what r is equal to. And so to solve this, we're going to have to take the square root of both sides. And we will wind up with r equals plus or minus the square root of a over pi. I don't know that they get any harder than that. Maybe I'll show you one more that's maybe got a fraction in it or something like that. But for the most part, they're going to follow this pattern. The one thing you want to think of when you're doing problems like this is that you're kind of trying to think backwards PEMDAS, right? You're going to do anything being added and subtracted to it first, then you're going to deal with what's being multiplied or divided, and then after that you're going to be dealing with the exponents and then the groupings. If I have A equals 1/2 the base times the height, B times H. And we want to solve this for H. That means we want to get H all by itself. So we're going to have to start undoing what's being done to it. The first thing I notice being done to it is we've got this 1/2 multiplied to it. So I'm going to multiply by the reciprocal of 1/2, which is 2/1, right? Which is the same as multiplying by 2. So here I would wind up with 2A equals, well, these cancel, and I have BH. So the last thing that I have to deal with at this point now, the only thing still being done to that H is I've got B being multiplied to it. So I'm going to divide both sides by B. And I will wind up with H equals 2A over B. So I'm going to do one more, and then I'll let you be, something that mixes things up a little bit. Last example is if I have A equals P plus PRT. We want to solve for T. That means we want T to be the only thing left over here. First thing I'm going to start doing is I'm going to subtract this P that's being added. So I'm going to go minus P. I get A minus P equals PRT, right? And then the only thing left I have being done here to this T is I have P and R being multiplied to it. So I'm going to go ahead and divide both sides by P, R. Right? And I'm going to wind up with, these will cancel out, and I'll just have the T. And I'll wind up with T equals A minus P over PR. Right? They're not going to be pretty because we can't combine the non-like terms. You're going to have variables for solutions. But the whole idea is to just get whatever variable you're trying to solve for all by itself on that side of the equal sign. I think that is more than enough examples for today. If you have any questions, make sure and let me know. I'm happy to jump into a meet and go over anything with you. Your assignment is on Delta Math. So get on that. All right. Thanks a lot. Bye.